Hello everybody, this is Dr. Hussein again in Power Electronics. Today we'll start in module number 4, week number 11, where we talk about DC power supply. And let me introduce the DC power supply. I will talk about its properties compared with linear power supply, switch mode power supply with linear power supply, where if you remember we started the semester just giving a brief about each one of them and we compare them and we give also brief about the applications. But here more details to come to discuss after we build our knowledge in DC converter, DC AC inverter, where we will discuss the flyback converter, forward converter, push pull converter, half and full bridge converter in this session. Okay. Now, first of all, you need to know that almost all electrical appliances available for humankind should have power supply. The power supply provide the required power with a specific specification required by the load, and then it gives the required power, voltage and current, their shape, their values. Okay. Now, also you need to know that around 80 to 85% of the faults occur in electrical appliances occur in the power supply. So if you understand this knowledge, the power supply knowledge, you can solve the problems, or 80%, let me say, of the electrical appliances problems. Now, for power supply, any power supply, we need to specify three important features, okay, or requirements. These are regulated output voltage. What this mean? We want to make sure that the output voltage is constant as specified on the nameplate of the appliances, regardless if variation occurred in the, or let me say, any variability occurred in the input or even in the load, it will keep the same voltage and current. The second point is isolation. We need to isolate input from output. Okay, providing isolation is wonderful. It's keeping them safe. And the third one is multi-output, which means that from our DC power supply, we must look to have more than one output. As example, if I talk about PC, personal computer power supply, we will find that the power supply, yes, the input is 230 in 150 hertz AC. It's converted into DC, but it gives 3 volt plus 3 4.4, 5 volt, 6 volt, 9 volt, 12 volt for different circuits inside the motherboard and the PC, the personal computer. So multi outputs is important also as a feature. Now, for linear power supply, we discussed this before. In linear power supply, the problems occurred here is, as you can see here, yes, we provide isolation by having transformer, line frequency transformer, which is working according to the frequency of the supply, 50 hertz or 60 hertz, okay? But this problem of this transformer is it's bulky, its weight, its size, which is not good, besides the losses of this transformer. And the other issue, the other problem, if you remember, we talk about the switch here. The switch is working in the active region as amplifier, or let me say as a variable resistance, which means we increase the losses. Now, in the new power supply, what we call it switch mode power supply, we will use large size, we will use a high frequency transformer. High frequency transformer is small in size because it deal not with 50 or 60 hertz, with high frequency. So it's very small in size comparing with line frequency transformer. The second issue, the switch will not work in the active region, and it will work as a switch on and off, as we discussed in the different power electronic converter circuits through the semester. Working the switch, when it works as active region for linear power supply, the efficiency reduces from between the range 30 to 60%. But the new power supply look to lower the losses, okay, increase the switching speed. Speed is an issue, and the voltage and current rated to be increase and reduce the cost at the same time. Size, weight also need to be reduced. Now, how it look like the switch DC power supply? You can see here the sequence. We have the AC input, as we know, Rectifier and filter. By the way, we put here EMI, electromagnetic interference filter, because we expected that there is high frequency switching occurred on the switch of the converter. So this filter is to protect from this electromagnetic interference. Now we didn't use isolate transformer yet. The output is unregulated filter, by usually we use capacitor as we explained the rectifier circuits. And here you can see I have inductance, capacitance, switch, diode. We can construct them in a way to give either DC-DC converter or inverter, okay, half bridge, full bridge, push-pull. And here we use high frequency transformer. High frequency transformer, it did the isolation, but it's small, very small, because it's working with high frequency. At the output of this transformer, we have rectifier filter, then we provide the output voltage. Now usually in this type of DC power supply, we need to have negative feedback, as you can see here, compare with reference to get error, and then this error go to the pulse width modulation controller to control it, because we need to control the switch duty cycle. If you remember T on, okay, which is DTS over TS, we need to control the time for the switch to work on and off. Again, high frequency transformer, and here is the circuit used to control the switch. Now for multi-output, we may use on the secondary side more than one, let me say, winding connect to a rectifier to produce different voltages according to the applications you are using this DC power supply for. Now, as a conclusion, we can say the advantage of the switch mode DC power supply, the switch is working as a switch, not as an active region, in saturation region and cutoff region. Okay, loss is almost zero or close to zero, because you know in saturation region the voltage is high but the current is almost zero, and the opposite happen in active region, in saturation region. In saturation the current high, the voltage is small. At the end both of them will lead to low power, and this will reduce the switch, let me say, the power losses, and the efficiency will improve to be from 70 to 90, comparing with 30 to 60 in linear mode power supply. Also, size and weight was reduced sharply because, as you know, we are using high frequency transformer. Sorry, it's proper to use electromagnetic interference because the frequency increase. Now, still, because we are using transformer, just to remind you, this is a revision. You studied this in level 2, but just remind you, the relationship between flux density and intensity is represented by this curve, as you remember, in quadrant 1, quadrant 3, and here the point is B remaining, and this is the maximum B. And you know that the transformer within a core, there is core here, and there is winding. This is the primary, this is the secondary. And if we represent it and consider the magnetizing inductance LM, it is inductance here. We can take it. This is input voltage, output voltage. Usually magnetizing inductance design, this high frequency transformer design, so the magnetizing inductance is as much as high to reduce the inductance, to reduce the current, because it's at the end hanging the current choke. Now, what type of let me say switch mode DC power supply? We can classify them in unidirectional, where the current working in one direction, or bidirectional, it's work in two direction. Unidirectional, we will take only two types in this discussion: flyback and forward. Flyback is just improvement happened by using insulated transformer to the buck boost. And forward, we use step down, or let me say buck converter. We improve it by using high frequency transformer. So rather than we have inductance, we will have high frequency transformer. For bidirectional, we will discuss the push-pull, half bridge, and full bridge. Okay, let me start. Just remind you also with pulse width modulation, everything to be controlled using pulse width modulation. Now you remember these two switches in push-pull here. Okay, this is push-pull if you remember inverter. And this is the rectifier, two diodes, as you can see here, center tap transformer, and the load connected here. Okay. Now the half bridge, if you remember, or full bridge, 4 switches. Okay. and we compare control signal with sawtooth and to know which switch to be on or off. As you can see here, T1 and T2 will be on for full bridge, and for push-pull or half bridge, one switch will conduct at a time. Now let me start with the phase converter. Flyback. Flyback, actually, what we did, you remember buck boost? We have a switch, we have inductance diode in the opposite direction to that of the buck converter, and energy store at the beginning here and release when the switch open. You remember this? Okay. And we can use it for buck boost, okay, either to have higher voltage than the input or lower voltage than the input. Okay, if we let me say rotate this one to be in this form, then we can represent the function by converting this inductance. Rather than we use inductance, we will use high frequency transformer. Transformer at the end represented by inductance, and this is the switch solid here to show the direction of the flow of the positive polarity. When the switch is on, current will follow here, and when the switch is off, energy storage will follow across the diode. Or let me explain in more details here. As you can see, I represented the transformer here. This is the magnetizing inductance, this is the switch. When the switch is on, as you can see here, short circuit, current will follow here and follow back to the supply. Plus, minus. Plus on the solid here, it means plus here, minus. When minus here, the diode will be open circuit and it will not conduct to the winding. When we open the switch, as you can see here, energy storage in the inductance will be released in this direction. So plus here, minus here. When minus here, okay, then the current will be following here, because plus here will be follow through the output. So if I come to V1, just V1 is the voltage across the primary, okay? It is the input voltage when the switch on, and when the switch off, it's not connected anymore to the input, so it's connected to the output. So if I transfer the output to the input, I need to multiply by, let me say, the term ratio. What about the flux and current? Flux and current, at the beginning, they increase and then they decrease. Store, release. Energy storage, magnetic energy to be stored and then to be released. The same thing for current. Current has the same shape, the same waveform. And for diode, when the switch is on, diode is open circuit, so zero current. When the switch is off, diode will conduct the output current, which will be released, okay, in this way. Now, as you can see here, the flux remaining phi of 0, and here the maximum. It happen at T on, and this is the end of Ts. From here to here is T off, which is 1 minus dTs. Okay. Now let me drive formula. Relate the output to the input. Okay, I can drive it using flux or using the current. For a flux, as example, phi for this part, the first part from 0 to T on. Okay, is the remaining, this one, Vd over N1 T. How we derive them? You know how you find, because we discussed this in level 2. It's a straight line equation. Minus y1 equal m x minus x1, and m is y2 minus y1 over x2 minus x1. You remember this from level 1, and level 2 we discussed this, how we find equation for this one. This is in the range of 0 to T on. If I want to find the maximum here, how much at V5 max, I will substitute for T here by T on. Now, phi for T on, between T on here to the end, to Ts. Phi, I found it to be 5 megs here minus this drop. Again, the same formula for straight line equation I used. Now, phi at this value at Ts here, okay, I can find it is equal to phi naught, right? As you can see here. So when I substitute it, okay, by T by Ts, and now phi of Ts equal to phi at T naught, okay? So when I equate them and simplify, I found the relationship linked input to output voltage, which say output voltage over input voltage equal D over 1 minus D. What is this? This is book boost converter, step up, step down converter, but multiply by turn ratio. Oh, another element